This week, we are going to start to learn about earthquakes. And before we learn about different types of earthquakes and earthquake waves and how to find earthquakes, we need to learn about the things that cause earthquakes. Earthquakes are caused by faults. A fault is a crack in the crust where movement occurs. A crack in the Earth's crust where movement occurs. So that's going to be our title today. A fault is a crack in the crust where movement occurs. So you can put that probably top center of your page. Before we learn about the types of faults that will lead us to earthquakes and how they work, we need to learn why does movement occur at these cracks in the crust. Movement occurs because of a force called stress. Stress is the force that pushes or pulls on the rocks. And this force could possibly be caused by plate boundaries, like we talked about a couple of chapters ago, but it doesn't have to be caused by plate boundaries. Stress is the force that pushes or pulls on the rocks, and this is what causes the rocks to move. If there is enough stress on the rocks, the stress can cause something called strain. If there is enough stress on the rocks, it causes strain. Strain is the deformation of the rocks because of stress. Deformation of the rocks because of stress. So what does deformation mean? If you think about the word to deform, that means to change shape. So strain is the changing shape of the rocks caused by stress. There are two different things that happen when strain occurs. The first one is called elastic deformation. If you think about what elastic means, if you had a piece of elastic, maybe out of a sweatshirt, you can stretch the elastic and it will go back to its original shape. So that's what elastic deformation means. You have a low amount of stress, and so if that stress is removed, the rocks will return to their original shape. If that stress is removed, the rocks will return to their original shape, just like a piece of elastic from a sweatshirt. If the strain on the rocks continues and continues long enough, then instead of elastic deformation, you get what is called plastic deformation. And the words are almost the same, but plastic deformation occurs when you have a high level of stress and instead of the rocks returning to their original shape, the changes in the shape of the rocks are permanent. The changes in the shapes of the rocks are permanent. So, to recap, a fault is a place in the crust, a crack in the crust where movement occurs. This movement occurs because of stress. Stress is the force that pushes or pulls on the rocks. If there is enough stress, the rocks will undergo strain. Strain is the deformation of the rocks due to stress. There are two different types of strain. Elastic deformation occurs first when the stress is low, and once that stress is removed, the rocks can return to their original shape. Plastic deformation occurs when that stress continues and is high, and once plastic deformation occurs, the changes to the shapes of the rocks are permanent. So now that we know what causes the movement associated with faults, let's learn about the three different types of faults. And we'll start with the one that we will be most familiar with. The first kind of fault that we will put on our notes is called a strike-slip fault. In a strike-slip fault, there is movement in one direction, and that direction is horizontal. There is horizontal movement as the pieces of rocks slide past each other. There is horizontal movement as the pieces of rocks slide past each other. And this is what occurs at a strike-slip fault. This description probably sounds familiar because we also used it to describe the movement that occurs at a transform plate boundary. So strike-slip faults can sometimes also be a transform plate boundary. They don't always have to be a plate boundary. They can occur in the middle of plates, but sometimes they are also a transform boundary. The example that we've used of this so far is the San Andreas Fault in California. To go along with the three different types of faults, these three different types of faults are caused by three different kinds of stress. And the strike-slip fault is caused by something called shear stress. Shear stress causes the rocks to move almost in a twisting motion. So if we drew two plates of rocks side by side along a fault line, and the fault would be this line right in between them, shear stress would cause one side to move in one direction and would cause the other side to move in the opposite direction. They slide past each other just like we described for a transform boundary. The second kind of fault that we will learn about is called a normal fault. A normal fault occurs when you have both horizontal and vertical movement. So the rocks are moving in two different directions. And these occur when the rocks are being pulled apart. A normal fault has movement both in the horizontal and the vertical direction and occurs when the rocks are being pulled apart. Normal faults are caused by a type of stress called tension stress, and that means to pull apart. If you had a rope and you wanted to make the tension in the rope very high, you would pull on the rope. So tension stress is where the rocks are being pulled apart. So again, if we draw our two sides of the fault, and we're going to angle them this time, two sides of the fault, the stress on the rocks would be pulling them apart in opposite directions. And as that occurs, one side of the fault moves down and the other side of the fault moves up. So you get both horizontal and vertical movement. The third kind of fault is backwards of a normal fault, and that gives it its name as well. The third kind of fault is called a reverse fault. And a reverse fault also has horizontal and vertical movement, but that movement, instead of being caused by the rocks being pulled apart, is caused by the rocks being pushed together. A reverse fault is caused when the rocks are being pushed together. This movement is caused not by tension stress, but by something called compression stress. Compression stress occurs when the rocks are being pushed together. And again, if we draw our sides of the fault, we're going to angle them again. Here are two sides of the fault. The rocks get pushed together, and as they get pushed together, one side moves up and the other side moves down. Almost like a subduction boundary when you have an overriding plate. One side moves up and one side moves down. So, let's recap. A strike-slip fault occurs when you have only horizontal movement and the pieces of rock are sliding past each other in opposite directions. This description should sound familiar because we also used it for transform boundaries. Remember, a strike-slip fault does not have to be a transform boundary, but it can be. This kind of movement is caused by shear stress. Shear stress causes the rocks to move side by side in opposite directions. It's almost described as a twisting motion. The second kind of fault that we talked about was called a normal fault. A normal fault has both horizontal and vertical direction or movement, and it's caused when the pieces of rock are pulled apart. That kind of stress is called tension stress. Just like when you pull on a rope, you're increasing the tension. When you draw a picture of what that looks like, the two sides of your fault are being pulled apart from each other. And as they get pulled apart, one side moves down and the other side moves up. The last kind of fault we talked about is called a reverse fault. A reverse fault has horizontal and vertical movement and is caused when the sides of the fault are pushed together. When the sides of the fault are pushed together, you have what is called compression stress. To compress something means to squish it together. So when you look at the sides of the fault and you start to push those sides together, that's the horizontal movement. As a result, one side gets pushed up and the other side gets pushed down, and that's the vertical movement. And now that you know what faults are and how they occur in the Earth's crust, how those rocks are moved by stress, how they are deformed by strain, either elastic or plastic. Now we can learn about the types of earthquake waves, and next week how those waves travel through the earth and how we locate an epicenter and how we measure the strength of those quakes. So, good luck with the rest of your week. Don't forget you have a 19-1 quiz on Thursday, and you can make a note card. Have a good spring break.